What is consciousness? I mean, really. For thousands of years, it's been one of the biggest, deepest mysteries out there. But what if the answer isn't some continuous, magical stream of awareness? What if it's something else? Something more like a movie? Today, we're diving into a radical new theory of the mind. And for the first time ever, we've got some physical evidence from a lab that might just prove it's right. Okay, let's get into it.
So just for a second, think about your own experience right now. It probably feels pretty smooth, right? Like a constant, unbroken flow of sights and sounds and thoughts, a seamless river of reality. And for most of us, yeah, that's what it feels like. But what if our brains are just playing a really, really clever trick on us? Because what if that smooth river is just an illusion? What if your conscious experience is actually built just like a film, a super fast sequence of individual static frames that, only when you play them together, create the feeling of continuous motion and time? Well, that's the wild idea behind a new framework called the Unified Theory for a Quantized Mind. It suggests that consciousness literally pulses into existence. It's not a constant hum. It's more like a rhythm, where huge clusters of neurons all fire together in these distinct, synchronized, and, well, quantized moments. So if this theory holds water, what would you actually need to, build a mind from scratch? The theory lays out this amazing blueprint, kind of a recipe with 4 absolutely essential ingredients for consciousness to pop into existence. And it breaks down pretty simply. First up, you need compartmentalization. Basically, different parts of the brain doing different jobs. Second, integration. All those different parts have to be able to talk to each other, like they're connected by information highways. Third, synchronization. You need groups of neurons to fire all at once, kind of like a choir singing in perfect harmony. And finally, the real mind-bender, quantization. The whole show has to happen in those discrete movie-like frames we were talking about. And this quote just nails the stakes here. This isn't just some philosophical thought experiment. The people behind this theory truly believe that if we can engineer a system that checks all 4 of those boxes, we might not just understand consciousness, we might actually be able to build it. Which, of course, brings us to the million-dollar question. I mean, it's a beautiful theory, but is there any actual proof? Can we find this blueprint in real, living brain tissue? Well, as it turns out, a brand new experiment may have just found the very first clues. Okay, let's head into the lab with researchers Tomoya Duenki and Yoshiho Ikirichi. They've come up with this incredible way to engineer networks of living human brain cells that they call loop connectoids. And here's the fun part. They didn't even realize it at the time, but they were about to put the quantized mind theory to a major test. And just look at how they did this. It starts with this engineered thing, a microfluidic chip with these tiny little chambers and channels. But from that, they grow a living, breathing neural network with actual bundles of axons forming biological wires that connect all the different nodes. It's a straight-up incredible feat of bioengineering. Now, the building blocks they use for these networks are called cerebral organoids. The easiest way to think of them is as mini-brains, tiny little spheres of human neurons that they grow in the lab. And these things self-organize. They can develop different types of cells and even create complex electrical activity, a lot like our own brains do. What's really cool is that the researchers didn't just build one network. They systematically built circuits with more and more complexity. They connected 2, then 3, and then 4 of these mini-brains together in a loop. They wanted to see how adding more parts to the network would change its behavior as a whole. Seriously, just pause and take a look at this. This is not a computer simulation. What you are looking at are 3 human mini-brains grown in a lab that are physically connected by bundles of their own living axons, forming a functional triangular circuit that's sending and receiving electrical signals. It's just wow. Okay, so the stage is set. We have this radical theory with a 4-part blueprint for a mind, and we have this incredible experimental model built in a lab. So the big question is, do these connectoids actually follow the rules laid out by the quantized mind theory? Let's go down the checklist. Prerequisite number 1, compartmentalization. The theory says you need a modular structure, and that is exactly what they found. By connecting separate organoids, they created these distinct subnetworks, and the network's modularity score, which is just a fancy way of measuring this, was way higher than in just a single organoid. So, check. But honestly, it gets way cooler. As they added more and more organoids into the loop, the network's behavior totally changed. The electrical activity got richer, way more complex, and it started to organize itself into this very special state that just happens to be the hallmark of super efficient information processing. That special state is called criticality. You can think of it as the absolute perfect sweet spot for a network to be in. It's balanced right there on the edge of chaos. It's not so rigid that information gets stuck in a rut, but it's not so chaotic that all the signals just become meaningless noise. It is the ideal state for a brain to actually think and process information. And this chart just shows it perfectly. This branching ratio thing is how they measure criticality, and the magic number, the absolute sweet spot, is 1.0. So as you can see, a single organoid, not even close. But as they started connecting 2, 3, and then 4 of them together, the network literally tuned itself, getting much, much closer to that perfect value of 1.0. Okay, so the connectoids were modular, and they were getting super efficient. But what about the final piece of the puzzle? The most radical idea of all, quantization. Could they actually prove that this living network could adopt a discrete, frame-by-frame rhythm? Could you teach a mini brain to have a frame rate? To figure that out, they came up with this really elegant experiment. Step 1, using a technique called optogenetics, they basically made the neurons light sensitive. Step 2, they started flashing a specific pattern of light, 1, 2, 3, on each of the 3 organoids in the loop, over and over and over again for 12 hours straight. And then step 3, they turned the light off and just listened. They watched to see what the network would do all on its own. And the results are, whoa. Look at this chart. The key thing to see here is that before they did any of the light stimulation, that 1, 2, 3 pattern happened every once in a while, just randomly. But after 12 hours of training, the network's own spontaneous chatter started to follow that exact 1, 2, 3 pattern way more often. The network had actually learned the rhythm. This is a phenomenon called sequence-specific entrainment. The network didn't just react to the light, it internalized the pattern. It adopted this discrete, quantized sequence as its own natural rhythm. This is the first piece of physical, biological evidence that a neural network can actually be trained to operate in discrete frames, the final pillar of the quantized mind theory. So what we have here is this fringe theory of consciousness and a lab experiment with mini brains that have just collided in this absolutely stunning way. But this is so much more than just a cool science fact. The implications here could change pretty much everything we know about the brain, both in sickness and in health. I mean, this research just kicks open the door to a whole new frontier. We now have a platform to build living models of human neural circuits. This could let us study what goes wrong in the brain's network with diseases like Alzheimer's or autism right there in a petri dish. We could test new drugs on functional human brain tissue without ever risking a patient. And if you look way down the road, this gives us a potential biological roadmap for creating truly intelligent machines, AGI that's not based on silicon, but on the fundamental organizing principles of a real mind. And that brings us to a final, really powerful thought. We are standing on a new threshold here, moving from just watching the brain to actually engineering its most basic circuits. And as we learn how to assemble these building blocks of a mind, it forces us to ask one of the most profound and maybe even scary questions of our time. What should we build next?